All right, what's happening, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we're going to take a look at example number 6 for circular trig functions. And that is finding values, given a point, and working with the angle itself, finding the angle as well as the reference angle, and a couple other pieces about that. But we're going to be given one clue, and that one clue is just going to be the value of the point. All right, so just a little bit of review from last time. With example 5, cosine, sine, tangent, they're all going to be related to x, y, and r. So depending on where you are, that is going to kind of work with that. But let's go ahead and take a look at plotting this spot. So 6, -3. So if I draw that, I know that's going to be down here in quadrant number 2, or quadrant number 4. So 6, -3, that's where my point is located. Now when I draw that reference triangle, again, the perpendicular is going to go right to the x-axis. Make a little box, because that's how we know it's perpendicular. And then we're going to draw the angle there. Now, as we go through and do this, the angle itself is actually from here, because remember, we're going in a positive direction, so the angle will go all the way around. So that would be theta right there, that angle. More on that in a little bit. But we would draw that, and we have the coordinates 6, 3, or -3. So that means the 6 is going to go along the x-axis, and the -3 will go on the y-axis. Now, we've got a x-coordinate, a y-coordinate. The only spot we're missing is the r. So we got to find the r. So I want you to think about this like a squared plus b squared equals c squared, right? Those were, that's Pythagorean theorem. So instead of a's, b's, and c's, we're going to use x squared plus y squared equals r squared. Now we're solving for r, and the r value, remember, always going to be positive. So when we do that, so the r value is going to be x squared plus y squared, the square root of that sum. So you can just go ahead and plug in the x value, which is 6 squared plus, and then -3 squared. When we find the sum of those two and square root of, we're going to get the square root of 45. So, I mean, you'll be able to use calculator and that kind of stuff for it, but 36 plus 9, you end up with 45. Now, here comes the kicker. You've got to simplify square root of 45. So, a lot of people do that a whole bunch of different ways. Whatever way works for you, you've got to simplify that. So, here's one way. So, if you get 45, you need a prime number. That goes into 45, and I'm going to start with 3. 3 goes into that 15 times. And then 3 goes into 15 5 times. And 5 goes into 5 once. Yay, we've got a little birthday cake. So I know that's one technique some people use. So that means every pair on the outside is going to go outside the radical. And then whatever's left is going to go inside the radical. So the value of r is going to end up being 3 square roots of 5. Boom, done. Now, for the next piece, so we figured out what r is. So that was part A. And then for part B, we got to figure out what the cosine is. And cosine, so here's part B right here. So cosine of theta is going to be this ratio of the x-coordinate over the r-coordinate. And I know the x-coordinate is 6, and the r, we just figured that out, that's 3 square roots of 5. Now I got to reduce that, right? So 3 and 6 can simplify. So you're going to have 2 over square root of 5. Well, 2 over square root of 5, man, I got to go ahead and rationalize that. So again, we're going to multiply top and bottom by square root of 5, which is going to give us 2 square roots of 5, all that over 5. Bam, that's a wee bit of work there. Yes, it is, but I know you all can handle it. So that is the value for cosine of theta. Now to figure out cosecant of theta, so cosecant is very similar to sine. So cosecant of theta is going to involve the y-coordinate and the radius. So when I look at that, I'm going to have -3 for the y-coordinate over, so let's just go ahead and zoom in on this here. So I'm going to have -3 over that 3 square roots of 5. And again, I can simplify that, which is real nice. So then that is going to end up giving me 1 over square root of 5. Don't forget the negative, though. And when we rationalize that, so when you rationalize that, you multiply the top and the bottom by square root of 5, you're just going to end up with negative square root of 5 over 5. And that's it, you're done. So the cosecant value would be that piece right there. Now, here comes where it's a little bit tricky, finding the reference angle and then the actual angle itself. So the reference angle is going to be this angle that's right here. I'm just going to put a little dot right there where that spot is. So for that reference angle, because that's, remember, I want to get back up to the x-axis. So I got to figure out, well, what is that stuff? What's going on right there? So to do that, we're going to use either our calculator, and if you use a calculator, make sure that it is set in degree mode. All right. Now, if most of you are going to probably use Desmos or some other graphing utility besides that, when you look at that, same thing with Desmos. Now, with Desmos, you're going to want to go over to the piece that has the square root. So let's see over here. So that part right there. So this graph, you want to make sure that that is set on degrees. So if that's not set on degrees, get it set on degrees, because that's critical. If you leave it set on radians here like this, how it's dark and gray, it'll give you the wrong answer, bro. So make sure that junk is set on degrees, because otherwise it's going to be wrong. So we'll do that, and we'll come back to this momentarily as we take a look at how to type that in. So first things first, we'll get our calculator set up, and then for this piece, so the reference angle, now I'm given the coordinates 6 and 3. So that means I'm going to use arctangent of that ratio. So the opposite over the adjacent, or y over r. So arctangent of -3 over 6 is going to give me this value. All right, so when I type that in to my graphing calculator, graphing utility, whatever you're using, so again, you can get the little piece right there where you go into the keyboard, and then functions, and an arctangent is going to be one of them, and then we have -3 over 6. So when we key that value in, we get -26.565. All right, so that's our value. So -26 and it was what, 565. All right, so we got -26.565. So that is my reference angle, actually, because the reference angle, remember though, it's got to be between 0 and 90, and it must be positive. So that reference angle is going to actually be 26.565. Now, the actual angle itself, so if you think about this for a second, if we were going to make one full revolution all the way around, we'd be at 360 degrees, right? So for that, to figure out the actual angle, so for part E, so I'm going to do that one in red, we'd have 360 degrees. So theta, the actual angle, is going to be 360 degrees minus my reference angle. And I want you to write that 360 minus reference angle down, because I know that's going to be a key piece when you look at that. So, and I know my reference angle is 26.525. So that means theta, and this is where it's real nice on the calculator, right? 333.49. You can leave it as 333.434, or you can round that up to 333.435. Either one of those is okay. So when you do that, just be real careful on your subtracting and your arithmetic there. Now let's talk about points here for something like this. Of course, you get 1 point for setting up your drawing correctly. You get a point for finding the value of r. You get a point for finding the cosine, a point for finding the cosecant, a point for getting that reference angle, and then a point for finding the angle. All right, so that's it on this one. Come on back. Let's take a look at the 2 clues one, where we're going to rock that one out. All right, thank you guys for watching. You have a great day. Peace out.